Well, good morning. I'm Jeff Pillett. I'm Director of Energy Assurance for the National Association of State Energy Officials. It's my role to work with states to help them build an analytical capability to assess energy markets and track supplies as part of their energy assurance work. They really need to be able to have the ability to understand how these markets work so as to assess the severity and duration of shortages when they occur. Today we're going to begin, as we typically do, with a look at the weather. And I'm pleased to introduce Michael Halpert, who's the Deputy Director of the Climate Prediction Center, who's going to give us their current prognostications as to what we'll see over the next few months. Michael.
Thanks, Jeff, and just a couple of corrections when we're going to take a look at the climate, not the weather. Okay, the weather's raining, I don't get into that. One other small correction, and I only bring it up because it will explain a little bit further, is that I guess I'm technically still the deputy, but I'm also the acting director at CPC, and while that comes with a great title and nothing else, it does mean that I have to take appropriations law class, and that happens to be going on this week, so I'm playing hooky right now, which I'm actually happy about, so thank you for scheduling this during this week. But it turns out that I do need to leave when I'm done with my talk, so I apologize in advance. So if there's any questions, you won't be able to catch me at a break, so you'll have to catch me right now. Turns out I was looking through my old talks, and this is the 11th time I've been here. So that either implies they like my talks and forecasts or they're too lazy to find somebody else. And again, I don't quite know which that is, and there we go. I'm going to use a similar outline, so we'll talk a little bit about what the outlook that CPC issues actually means, and I'm going to spend even another minute or two on that than I usually do, because I've come to learn during my almost 30 years now at the Climate Prediction Center that folks don't really know what our forecasts mean and how to properly interpret them. After that, we'll look back at last year. I always believe in doing that, whether we were successful or not, because it turns out you learn a lot more when you're not successful, and so we'll be learning a lot this year. Then we'll look at what's going to hopefully or potentially affect the coming winter and as well as the forecast. So for those that want just the forecast, well, you can play on your phone for a little while till we get to that. These are our seasonal outlooks for average temperature and for total precipitation during a 3-month period. The forecasts are not going to tell you how cold or how much you'll get. They'll tell you the likelihood that we'll see above normal, near normal, or below normal temperature and precipitation. There are areas on the maps, and this year maybe more so than other years, where we really don't have much of an indication what's going to happen this winter, and we label those areas as equal chances, and basically that means that there's no tilt in the odds towards any of those 3 categories. It's just as likely to be warm as it is to be colder than average or near average. And in those areas where we do tilt the odds one way, what we're showing on the map is the most favored, but it's important to understand, and when we go to an example, that's not the only valid outcome. In a probabilistic forecast, anything can happen, and anything should happen. If the forecast was for a 50% chance of rain, well, you should expect that half of the time it doesn't rain. If it always rains, then your forecasts are not what we call reliable. If you're always correct, if it's always what you put on the map, then that probability should be 100%. So I show a couple of examples, a couple of points on the map, and this is just a forecast from a couple years ago, but you'll notice that each point on the map has 3 probabilities with it. So in the areas that are red, so those are favored to be above average, but they're not necessarily strongly favored. For this particular area in northern Georgia, it's a 38% chance of above. The near typically stays fixed at 1/3, and then so that it becomes less likely to be below. In an area where we show blue on the map, again, we elevate the likelihood of below. Near stays the same, and above. But even in a case like this, you would expect close to 2 in 10 years they would see above average temperatures, and that's just the nature of a probabilistic forecast, and in particular a climate forecast. And I've got a point somewhere. There we go. So these forecasts that we issue, we actually go out 13 overlapping 3-month periods. So when we issued the forecast that I'm going to talk about, and typically this slide, I didn't update it on purpose. You'll see it says, whoops, next outlook is October 17th. Well, that would have been the case if we had been standing here in early October like we usually would be. So I'm going to be presenting the outlook that was issued on October 17th. We will update these outlooks one more time, November 21st. And my public affairs folks are here. I wanted to just let folks know that when we issue that forecast, and that will be actually the official final winter outlook, we will have a press release and a press teleconference, and I'm sure NOAA folks will be issuing the alerts to that, and you'll get to hear me again if you so desire. So now let's look back at last year, and I kind of have to do that. So when I was standing here last October, we had kind of on the edge of an El Nino developing, and we thought that it potentially would develop. So that kind of forms a basis, a backdrop for the outlook. Another phenomena that I'll talk a little bit more about, something we call the Arctic Oscillation, is something that is rather unforecastable at seasonal timescales at this point, but it certainly adds uncertainty into the forecast. We oftentimes fall back when we don't have a strong physical basis into what the trends have been, so what the recent past has been compared to our base period. So we issued a forecast that was tilted towards El Nino, but as I said, and I think I called during at least our press telecon, I said that this is one of the more challenging forecasts that we've had to issue in recent years. I think I'm going to use that line again, so you can put that in the so anyhow, there's what the forecast was. That's on the left, and so we had favored above average temperatures in here and below through this, and the white areas were kind of a toss-up. And here's the verification, and you can see that there's a little bit of overlap, and actually the forecast, it scored a 1. So let me tell you what that means. It's better than a 0. A 0 means that we had no skill. It doesn't mean we got everything wrong. If we got everything wrong, it would be a minus. You can actually, this metric can go negative. So we stayed on the plus side, but just barely. The interesting thing is that if we looked at the next season with this forecast, so if we went, and I think I did this, yeah. So if we had looked at the January, February, March period, which a lot of folks kind of consider as winter, because if you want to say winter starts on December 21st, well, then it's kind of closer to January. This forecast, while still not great, would have certainly done a lot better, and it kind of highlights the uncertainties. We had maybe some ideas of what might happen. It just kind of happened later than we thought it would. So we were concerned, and we thought we might see some cold in this area, and some of that happened, and then some of the warmth. Anyhow, that wasn't the forecast, and so we can't go back and rewrite history. But I just want to show kind of the variability that we oftentimes see during the winter season. So here we're looking at the 4 months, December, January, February, March. Temperature departures are anomalies in degrees Fahrenheit. The shades of red are areas that were above average. The shades in the blues and purples were below average. So, and probably, even though we experience winter, we probably don't necessarily remember it unless it's really noteworthy. But it turned out last December was really warm over much of the country, and particularly in the east. And it stayed warm in the middle and the eastern part of the nation in January. It got cold, particularly in the mountains out west. February was kind of a transition month, and then we ended up with this pattern that we were kind of not exactly hinting, but we were concerned that we would see a pattern like this for more of the winter than we did. So you can see when you're issuing these forecasts back in September, as when I would have been talking here in October or even November, weather forecast people are maybe come to rely on what's going to happen in the next couple of days, maybe out as far as a week. when you get to longer term, the uncertainty really grows, and really the phenomena that impacted these particular months are phenomena that impact on what we term the intraseasonal timescale, but and I won't go into the scientific jargon as to what these phenomena are, but let's just say that when we're issuing forecasts out for the winter, we have no ability to even know that these will develop, no less impact what's happening. So I did mention that when we issued the forecast, we had kind of a borderline El Nino case, and so that's what we're looking at here, what the ocean temperatures look like in basically September. So the key area for El Nino is this area we call Nino 3.4, and it was modestly warm, and we have this whole series of models, and they're all kind of forecasting, you know, maybe a continuation, maybe a little bit of a warming from that point. So we kind of had that as a backdrop. Well, what actually happened was that the ocean kind of played a trick on us and all the models, and so we didn't even get the El Nino forecast back, and that's supposed to be an easier forecast. Years back, people said, we've got this one licked. We know how to forecast El Nino. Well, not always, apparently, because you can see while we didn't actually develop a cold event or what we would term a La Nina, we certainly, after a brief warming in the later part of October, much of the winter, actually, we had below average sea surface temperatures. And that probably did impact the circulation through various processes. Certainly not something that we were looking for when we were issuing the forecast. So what do we think is going to happen this winter? So we always start looking at the state of the tropical Pacific and El Nino or La Nina. And we've had a rather prolonged period of what we term ENSO neutral, so neither El Nino or La Nina. Goes back about 1.5 years now. And we think that's going to continue through the winter and looks like right now even well into the spring. So why is that important? Well, it kind of one of the strong signals that we typically rely on we expect will be absent. And so it likely means that other more transient features will play a role in the upcoming winter. This is just that same plot that shows all the different model forecasts. And so these red lines here indicate the forecast of neutral. And so certainly for winter, the overwhelming majority of the points fall between those lines. There does look like some hint that maybe as we go through the winter into the summer, maybe we'll start to develop El Nino. That's kind of too far out, and it's really uncertain. We have what we call the spring barrier with regards to forecasting El Nino, so I wouldn't really pay too much attention to any forecast past the spring. And so there's largely El Nino. We do largely neutral. We do have now a subjective forecaster-based outlook, which is on the right. And you can see these long bars here so that the probability of neutral persisting through the winter stays well above 70%. So doesn't look like we're going to get much help out of the tropical Pacific. In my earlier summary slide, I talked a little bit about the Arctic Oscillation, or as folks more regionally located call it, the North Atlantic Oscillation. Oftentimes dominates what happens during the winter. But as it says on the bottom, that the ability to forecast it on a seasonal time scale is I'll be charitable and call it limited. There is a lot of research ongoing into that topic. That's probably one of the really interesting and noteworthy areas of research at this point. There's been a number of meetings and workshops. One that took place in September. There's another one in Iceland in a couple of weeks that I don't get to go to. And then there'll be another one in, I think it's February or March, that NOAA is putting on, really trying to understand and do a better job or seeing if it's even possible to forecast this. My own sense is that we might be able to forecast it kind of the way we forecast temperature and precipitation, with like a tilt towards one phase or the other. I don't think it'll be a forecast that we issue, at least confidence-wise, with regards to El Nino and La Nina. but maybe even having a tilt will help to inform and tilt our forecast a little bit. Just for those that maybe don't know what the AO or the Arctic Oscillation is, the easiest way to think about it is it's a phenomena that influences what we call the polar jet stream. On the left side there, that's kind of what we see when we see it in its positive phase. And what happens is the jet becomes stronger, and you can, in a simple sense, just think that it keeps all the cold air bottled up over the poles, so it's cold up at the poles and it's typically warm in the mid-latitudes. The right side is the one that's maybe more interesting for those that like cold and snowy weather. That's the negative phase, and that jet weakens and then oftentimes become quite wavy and allows cold air into the mid-latitudes. Now, certainly this is just a cartoon. It's never quite that regular or not. But that's in a simple sense as to what the phenomena is. We do look at it, certainly. We have decent records back to at least 1950. Here we're looking just at this index for the winter months, December, January, and February. And you can see probably what catches most people's eyes is this big bar down here in the winter of 2009-10. And for those living in the East Coast, remember the cold and snowy winter we had with that. But you can see the last couple winters fairly modest in its projections, either towards positive or negative. Now, this potentially could mask a lot of intra-seasonal variability. You can have a strong negative one month and a strong positive, because the persistence of this is oftentimes not that strong. So you will see periods during a winter when it can be strongly positive, and you'll have a lot of warm weather, and then it'll become negative for a couple weeks. So that's kind of the average case. The persistence of it through a winter is probably more the exception. So I've kind of talked about El Nino, and I've talked about other phenomena. Let's get into how we issue or what goes into a forecast right now. We're relying more and more on computer simulations, model forecasts. Here we're looking at 5 different forecasts. You'll notice that there's a space here for a NASA forecast. Well, they were shut down back in early October, so we weren't able to get that forecast. But this one here is the one that we run at the part of the Weather Service. There's 2 different models run from actually up in Canada at the Canadian Met Service. The Geophysical Fluid Dynamics Lab runs one, and then there's an NCAR model. And you can see there's certainly a lot more red on the maps than blue on the maps. Actually, other than this GFDO one, there's really not a whole lot of blue on any of these maps. So they're all kind of pointing towards a milder than average winter. One thing that's important to remember or realize with these forecasts is they're not weather forecasts. So these do not have the skill or reliability of the forecast that we might look at that told us yesterday that we were going to have rain this morning. The skill of these forecasts is what we would term modest. One way we try to increase that skill is by doing what's called a multi-model ensemble, which is a fancy way of saying we just average all of them. It turns out that does give you some additional skill. So these are now, what the NMME stands for is the National Multi-Model Ensemble. This one here with an I in front of it is actually an international one. That's the Weather Service model combined with 3 European models, part of a project called EuroSIP. You can see that the NMME forecast is much warmer than the IMME forecast. Interesting, the IMME does include the European Center model, which at least in weather time scales is oftentimes looked at with a lot of favor. It's very skillful. Seasonal forecasting really isn't much better than what we're doing here in the US, which is to say none of them are really all that skillful. But we do, given the fact that it's quite different, it kind of does give us indications that at least the European models are maybe painting a little bit of a different picture than our own model is doing. Last main tool, and oftentimes this is what we end up falling back on, is what we call optimal climate normal. It's kind of a fancy 3-word term that just means what the trends have been. We've recently, actually I need to update my slide. It says what we do is we compare the last 10 years to the base period. It turns out if you look at a longer period, 15 years, it becomes a little more skillful. So we actually now look at the last 15 years. Some might think that that's kind of all I know. It's always the planet's getting warmer, so therefore that trend must always be upward. And while in a global sense that's the case, in a regional sense it's not so much. Here I just wanted to give an indication of that. These are based on land temperatures, and they compare different decades to the whole 60-year mean. So up here, this is what the decade of the 50s looked like globally compared to that 60-year mean, coming down 60s, 70s, 80s, 90s, and then the last full decade. And certainly there's a strong sense that it was colder in the 50s, and as you get towards the last decade, it's warmer. But if you kind of drill down and you look closely, you can see the 50s were actually quite warm relative, certainly to much of the rest of the globe across the southeastern and the southern part of the U.S. And if you get to the last couple of decades, you can see that that area hasn't seen as strong a warming trend. So, and this is averaging all seasons and all years. If you look at it even finer scale as to just like the winter season, and we'll do that right now, you can see the trends for winter over the U.S. Are actually not very impressive. And this is kind of another factor that goes into the forecast, and it's why when I show the forecast, you're going to see probably more white on the map than I'd like to show you. But you can see that the only areas that are, and I won't even say significant, but are really warm enough, at least a quarter of a standard deviation, which really isn't very much, are over the south and then a little bit into the northeast and up over the Great Lakes. Much of the country, really, the trends over the past 15 years have been virtually zero. So no trend towards below average temperatures anywhere, so you can get some cold years in there, but we haven't really seen any consistency to that. So the rationale for the outlook, you know, I would hope that if you're paying attention with me here, you're going to see that we don't really have much to base this forecast on. We have a very neutral tropical Pacific. We have uncertainty because of phenomena like the Arctic Oscillation. We don't have much in the way of trends, but we do have to issue a forecast anyhow. And so having said that, I will issue the forecast, or at least show the forecast. We issued it back a couple weeks ago. So at this point, and remember that, you know, things could change in a couple weeks. Certainly the trends won't change, but maybe our models will all come together, or maybe El Nino will develop, I don't know. But at this point, there's a couple areas that we kind of tilt a little bit towards above average temperatures. But remember, even in those areas, there still is some likelihood or some probability that temperatures won't be above average. And pretty large areas right now that there just really isn't much to base a forecast on. I know folks sometimes don't like probabilities, they like numbers, so we try to give them a number. I don't in particular know if there's a lot of value in this product, but we do show it every time. What this is if you looked at the distribution and you just shifted the median, the 50th percentile, that kind of translates into maybe 0.5 degree Fahrenheit in these areas. If you look at it in terms of heating degree days, this whole forecast comes out to be, if it were to verify, and so all these areas were to turn out to be exactly near average, and these areas would be what these numbers are. We would have 1% less than the base period, which is still 3% more than last year, because last year for December, January, and February was rather warm. Anybody interested in precipitation? Not much more. I didn't really show any of the tools, but again, there's some trends for below average across parts of the South, and that's really about it. The next 6 temperature outlooks, so starting with December, January, and February, across to February, March, April, and finally through the spring into almost the summer. Actually, a little bit right now, a lot of these are what the trends have shown. So it's interesting that at this point, the winter forecast, December, January, and February, turns out has the smallest trends of any season. So it kind of is the hardest one basically to forecast at this point. But you can see as you head through the winter and into the spring, there is some tendency for a forecast to go towards the positive side. And that's just the forecast in words, and I think I'll stop there and take any questions before I run off to law class. Thank you. Anybody awake? Sure.
We were talking earlier about the hurricane season. Do you want to make some comments about that?
Do I want to make any comments about that? Well, I'll give the same comment to you. Certainly, when we get completely through the season at the end of the month, we'll issue a summary. You know, one of the things I didn't talk about, I just kind of showed a little bit about what happened last winter with regards to our forecast. The science of understanding what happened is not really much easier than the science of forecasting what's going to happen. We call it attribution, and a lot of times we're not very good at that either. Now, I'm not going to guess as to why the forecast didn't live up to expectations. I will point out, though, just like these forecasts, they are probabilistic forecasts. And when we issue the hurricane forecast, we say that it has a 70% confidence. So it's actually much more confident than these forecasts are. But even 70% means 3 in 10 times will be wrong. And so I'll just leave it that maybe this is one of those 3 times, and so we should be better off next year, maybe, I don't know.
Is there anything that you can say now about water temperatures in the Atlantic rather than the Nino is the Pacific?
Right.
The warmer water in the Atlantic has sometimes been identified with.
It does play a strong role, and that's one of the reasons why we were fairly confident that this hurricane season would be above average, because the Atlantic, the tropical Atlantic in particular, is above average. And looking through the historical record, there's very few years when you see a warm Atlantic and you don't see above average activity. So that's one of the things. I mean, my suspicion is that there was a lot of influence from the extratropics or the mid-latitudes kind of suppressing activity, and if that's the case, that explains why we're 70% for these, because that's, again, not really forecastable at those kind of lead times. As far as the Atlantic influencing the winter, it's not as simple a case. I mean, certainly the models have all the SSTs built into them, and so that's where they do factor that in. We have some statistical tools that try and leverage that. There's one school of science that says that the Atlantic Ocean temperatures influence the Arctic Oscillation. And so we've looked at that, and if it's there, it's very weak. There's actually a number of different factors folks are looking at. One of them is Arctic ice and the decrease that we have documented quite well. So it kind of makes the polar regions warmer, and if the polar regions are getting warmer, that can have influences on that polar jet, which could almost lead to colder mid-latitudes, which is kind of an interesting twist on climate change. But as I mentioned, that's really still in the realm of research and science, and I'm sure those types of phenomena will be discussed at the couple of meetings. And, you know, maybe next year or 5 years, if I'm still working and standing here, we'll have a better way or some way at least to forecast the AO.
Your last point, drier than average in parts of the southeast and southwest, does that imply that precip forecast for the winter period for the rest of the nation is normal?
It's not normal, remember. That goes back to equal chances. And so people like to equate that with normal, but really what it is it's normal probabilities, so that there's just a 1/3 chance. Really, it's I would say a flip of a coin, but I needed a 3-sided coin to accommodate that. So,
A real quick second one. I know this is someone else's department, but any idea when we'll see 2010 census-weighted heating and cooling degree days?
well, you know, that actually, have we been emailing about this? Or
No.
Somebody has. Okay, we've been, I actually think that we've been doing some of that. They used to come from the National Climatic Data Center, and I'm not sure that they're doing them or they're doing them the same way. So the CPC, the Climate Prediction Center, has been doing it. If you go to our website, it's possible we might have that stuff on there now. I know that we've had somebody working on it for the last couple of years, but I thought that it was completed, actually, but I don't know if it's exactly what you're looking for, but I know that we've ended up creating our own. All right, and with that, I think I will depart. Thank you very much.
So to provide some context, if you think about weather and climate, you know, last year we had 11 events that caused in excess of $1 billion worth of damage. So these can be pretty significant, you know, kind of events to consider. So having a good understanding of what we're dealing with in the area of climate and weather is certainly helpful and important.